Hello, welcome to Petals for your troubles.
Are you troubled?
If you are,
Then come, come, come!
ta-da! We have Coulomb's law. Before we start with the question, let's start with a little history. First, through experimentation, Coulomb discovered that the magnitude of electrical force between two charged particles is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. This statement is called Coulomb's law. So let's get to the question. The figure that will be shown later on will have 3-point charges that lie in the x and y plane. Determine the magnitude and the direction of the net electrostatic force on Q1. So let's get started. Let's start answering the GASA. For GASA, we have G, given. We have 3-point charges which are Q1, Q2, and Q3. For Q1, we have plus 4.0 microcoulomb. Q2, we have negative 6.0 microcoulomb. And for Q3, we have negative 5.0 microcoulomb. And for the angle given, we have 73.0 degrees. For the radius, we have R12 is equals to 0.15 meters, and for 13 we have 0.10 meters. Next, we have the asked. What is it asking for? It is asking for the magnitude and the direction of the net electrostatic force on Q1. So, we are going to try to look for the magnitude and the direction for this question. The third step, the S, or the solution. The thing we have to remember are the formulas to use and the constants. We have Coulomb's law, F force is equal to K times the absolute value of Q1 times Q2 divided by radius squared. The constants we have K and microcoulomb, which are the said numbers. So first, we're going to look for F12 because we are focusing on Q1. So for F12, we have this Coulomb's law formula and we just have to insert the values needed. So we have K, we have Q1, Q2, and we have R, which is 1.15 meters for this given. We can just input this in the calculator and boom, we have 9.6 for the answer for F12. For the F13, whoops, we have no space, so next page. For F13, we have the same formula, K times the absolute value of Q1 and Q3. So for K, we have this constant and we just put the numbers in the calculator once again. So the answer is going to be 18N. After getting the variables for F12 and F13, what I'm going to do is to make the chart for the X plane and the Y plane. For this, I'm going to use SOHCAHTOA. So we have 9.6 cos 73 for the X and 9.6 sin 73 for the Y. Correspondingly, we have the answers 2.8 for the X and 9.18 for the Y. For further explanation, I'm going to draw the figure right here on the right. We have the corresponding meters, the Y plane, and the X plane for you guys to understand better for the visual learners. Next, moving on, we have F13. We have 18 for the X and 0 for the Y. The reason F13 does not deal with SOHCAHTOA is because it simply lies on the X plane. For the next step, we have A, which is for the answer. So we are going to add the variables we had for the X and the Y, which is going to lead to 20.8 I hat plus 9.18 J hat. Because of the significant figures, which is 2 for this problem, we're going to lead to 21 I hat plus 9.2 J hat. And we're going to look for the magnitude. For that one, we're going to use this formula, which is the square for x squared plus y squared. Put it in the calculator, we're going to have 22.9. Following the significant figures, we're going to have 23n. For the angle, we're going to have tangent, the absolute value of y divided by x. Put it in the calculator once again. And boom, we have 24 degrees. And lastly, for the direction, going back to the figure, we can see that the Q2 and the Q3 is a negative, and the Q1 is a positive. So it directly goes. It gets attracted to the Q2, which is going up, and the Q3, which is going to the right side. So we can assume or imply that it's going to be positive, positive, which leads to northeast. So for the final answer, we have 23n for the magnitude at 24 degrees northeast. Boom! This is the final answer for this problem. Ta-da! Thank you for watching. 감사합니다.